Okay, last question in this. Yeah, here also I will state if you have been following the solution, my solution for the for this exam. Here also I said that I think there's a problem with this question. It's solvable and it's okay, but it's I think the use of specific words here is bad, and there are things that are unclear here. Nevertheless, when they talk about a pendulum rod, they talk about a physical pendulum, which means that you know we have a pendulum swinging back and forth, but 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 it's what is it? You know, it's just turns out it's just if we have an axis here, okay, we have this we have this rod connected here to the axis, and it gets an initial velocity v naught, and it just you know just oscillates back and forth. Assuming there is no friction, it will you know happen continuously and infinitely through time. And if there is friction, it's gonna slowly slow down and stop. Now, what I didn't like about this question is that they call it a pendulum rod, which is, you know, it's I don't know. I've never heard this term being used. It's not a professional term. Nevertheless, this is what it is, and it tells us it's moves from the vertical position. I don't know, a vertical position could be upright above, you know, the axis, but that's not what they mean. What they mean is they mean like at the bottom, like I drew for you. So it gets a hit or something apparently, and then it starts oscillating a vertical position at the bottom position, um, which is false. And then I start reading. Of course, you can read all the others and convince yourselves that they are not false. But let's look at A. In the absence of friction, I already told you that. In the absence of friction, the pendulum tends to come to a stop after a certain time. That's not correct. I told you that in the absence of friction, the pendulum is just gonna keep swinging indefinitely in time. So this is false. So this is why we would have chosen this answer. And of course, you can read the rest of it. For instance, E, the pendulum describes a circular arc during its motion. Yes, it does. It's not false. It's you can see that this um, creates like a circular arc, only an arc, of course, not a complete circle. Or this is completely fine, so it's not false. I can choose it. That's it. Hopefully, you're watching it, and if you like, comment, subscribe. Let me know if you like the videos. If I see that there's enough traffic and not like two or three people watch the videos, maybe it's a good thing to do. And I will I'll be very happy to solve exams from previous years. It's fun. So nice to meet you. Good luck, and I'll see you soon.